Model monitoring will require a little bit more work from what we had to do to monitor the data. Let's take a look at the chart here, at the diagram, not the chart. I keep calling it a chart. Let's take a look at this diagram here, specifically at the model monitoring section. In previous sessions, we built the quality baseline generation. We had a batch transform job working with the test set to generate all of the predictions. Then we took those predictions into a quality check step, and that quality check step automatically generated the baseline metrics that we are going to use to monitor the model. Is the model performance going up, down? How is it working? That's our goal. Now, notice that there are 3 inputs to that model monitoring job. The previous one, or the data monitoring job, only required the traffic from the endpoint, specifically the input features, and require the baseline metrics. Well, now our model monitoring job requires the endpoint predictions. So that's the traffic to the endpoint, just the responses from the endpoint. We already have that data because we're capturing that data. The baseline metrics, which we already know how to get because they were generated as part of our pipeline. But it also requires ground truth. And that makes sense. Like, the model is going to be making predictions. But if we want to understand whether those predictions are correct or not, we need to have a baseline. Or not a baseline, but we need to have a ground truth. We need to understand, hey, is this the correct answer for this input? That means that we're going to need labeling. This is the section that I have here in your setup. Part of your workflow will be grabbing the traffic that goes to the endpoint, grabbing some of that information, and generating labels for it. Because later on, we can use those labels as input to the model monitoring job. So the model monitoring job can decide, are these answers correct or not? So imagine just a setup in your company. The way that will look like is, well, your endpoint is capturing some of the data, let's say 100% of the data or 10% of the data, it doesn't really matter. And it's saving that data in S3. And you have that you have an application that connects to S3, finds any new information in S3, any new data, and grabs those requests and presents those requests to your labeling team. And your labeling team is going to look at that data and say, yeah, this penguin is a chin strap, or this penguin is an Adderley. They're experts. They know how to evaluate that manually. So the labels, the ground truth, is going to be saved in S3, and then you're going to use that as an input to the monitoring job. Now, how does the monitoring job knows this ground truth is related to this input? Well, through the inference IDs. Remember that when we are sending predictions, we're generating an inference ID. So by matching those two, the monitoring job will know how to compare. So let's take a look at the code to see what I'm doing. So obviously, I don't want to be labeling data here, and I don't want you guys to be labeling data just to test the notebook. So what I'm going to do is I'm going to generate fake labels. I'm going to do that automatically just so we can move through this quickly. First of all, I'm going to be creating a location here where I'm going to be saving the ground truth data. Just an S3 location, just a constant that I'm going to use later. Second, I'm going to be deploying the model. So this is going to be using the function that we created in the previous session to deploy a model. I'm going to be calling deploy model. That will give me a model that I can use. Third, I'm going to be generating fake traffic. Again, we also need fake traffic. So the model has something to capture and saved in S3. So I'm calling the generate fake traffic function that we created in the previous session. Here I'm checking and making sure there is actually data in that location. So you can see this is displaying Torgerson and 39.1. This is the input CSV, displaying the output, and the inference ID. This is the index or the identifier of this request. So when I generate labels, if I want to create a label for this particular request, I need to use 0 as the inference ID. If this was 27, I will need to use 27 because SageMaker will use those numbers to match them. So now I'm going to generate the fake labels. Again, this is just fake labels. So I have a process here that is going to create a random label for every value in S3. I know that the generate fake traffic function that I created before goes through the whole data set and generates one request for each value in that data set for each row. So what I'm going to do here is do the same thing, but just to generate labels. So I don't really care about the ground truth. I don't really care about that. I just want to generate a random choice. Keep that in mind because a little bit of math. If we had like Adelie, Chinstrap, and Gentoo were approximately balanced. They're not, but they're approximately balanced. Like we have the same amount of Adelies, more or less, than Gentoos and Chinstraps. And I'm generating a random choice here. Probably the accuracy of doing this is going to be about 30%. That is what we should expect to see. This here is a JSON that I'm creating that follows a very specific format. And that format I got obviously from SageMaker's documentation. If I had like a real labeling application, my labeling application will have to save the information following this format. The format is very simple. It has a ground truth data section. Inside it has data, which again, I'm just randomly saying Adelie or Chinstrap or Gentoo. The encoding is just going to be CSV. Then I have an event metadata section where I'm going to specify event ID. And this is just an index that I'm creating here. This event ID is a very unfortunate name. It should have been called inference ID. So it will be obvious that this should match with the inference ID from the captured data from the endpoint. They called it event ID. That's fine. Anyway, that's what I'm doing here. I'm generating this here. I generate all of these records for all of the data in my data set. And then I'm going to upload this file, this huge file, which is going to be a JSON-L file. With all of that information, I'm going to upload it in a specific location in S3. The location has to be very specific. So SageMaker explains, when you store ground truth data, you have to follow this pattern. Like it has to be a pattern to just save that data in S3. And you can get an explanation right here. Like if you get here, it's going to tell you what the format of the data should be. And it tells you exactly what the format of the location should be. That's awesome. That's great. I'm doing that. Again, keep in mind, the important thing here is I'm just generating fake labels. It's just going to be randomly. I'm picking in between Adelie, Chinstrap, and Gentoo. After doing that, now I can create a monitoring schedule because I have the three inputs that schedule is going to require. I have the endpoint that's capturing data. I have the baseline metrics that I generated in my pipeline, and I have the ground truth label. Okay, so how do we create a monitoring schedule? This time I'm going to be using a model quality monitor. I specify the type of instance count, how long is this process allowed to run, volume size in gigabytes, 20, and the role. Again, we did the same thing before, nothing changes here. This is the interesting part where we define the monitoring schedule here for model monitor. I have my model monitor, I'm calling create monitoring schedule, giving it a name. Now I need to specify an endpoint input. And this is a little bit more complex than before because now I need to provide extra information. So first, what is the name of the endpoint? That's going to be Penguin's endpoint. Then I need to specify what is the attribute, the inference attribute that the model monitoring should look at in order to determine what is the prediction. Remember, we're sending two attributes back. We're sending Adelie, and the confidence. So we need to tell SageMaker, use the first attribute or index 0. That is what I'm doing here. Use index 0 as the prediction. Forget about the confidence. SageMaker does not need that confidence. It only needs the final answer, which is going to be Adelie. If we were sending them in reverse order, then we will need to specify here 1. So index 1 will be the prediction. What is the destination of this? Awesome. What problem type are we trying to solve? Is a multi-class classification. The problem type is very, very important. And the reason it's very important, the problem type, is because that's how SageMaker knows how to compute the metrics that it needs to compute. Like if you were working on a regression problem, well, it's a little bit different to if you were working on a multi-class or a binary classification problem. Like the metrics that we will be computing, we will not will not be accuracy, right? The metrics will be RSME or whatever metric you have. What is the ground truth location? What is the ground truth coming from? This is the location, the S3 location where I saved my fake labels. What are the constraints or the baseline constraints that SageMaker should use to compare the model performance against? So I'm passing here the JSON file that we generated as part of the pipeline. The cron expression, like how frequently is this job going to run? It's gonna be hourly, just like in the previous session. Where is it gonna be saving the data in S3? All of the monitoring output, where is it gonna go? I'm just passing the location where that's gonna go. And finally, I'm gonna be saying, yes, please enable CloudWatch metrics so we can check all of that from the CloudWatch interface. It's pretty similar to the data monitoring job. I'm doing here the same thing now where I sleep for a few seconds, let SageMaker some time to catch up and create that monitoring schedule internally. And then I'm gonna call start monitoring schedule to ensure that my schedule runs as soon as possible. I don't have to wait an hour or even more than an hour. In the previous session, I explained how the SageMaker treats that schedule. It's not gonna run it every 60 minutes. It might take up or minus or down 20 minutes. So it might run it in 40 minutes or 50 minutes or 80 minutes, right? It's just around that time. By calling start, I ensure that this is gonna run within the next 20 minutes approximately. And after running this, and after waiting the time that it takes for SageMaker to actually execute and do the monitoring, you can check for violations. I created a function in the previous session that's called check execution. It's gonna take care, that function is gonna take care of everything you need to check that schedule. Did it complete? Are there any violations? And print all of those. So the last time I did this is the output that I got. The status was completed and it found 5 violations. Now, why do you think it found violations? Well, the labels that I'm creating are crap, are just random values. So of course it's gonna find violations because it doesn't match the accuracy, the baseline accuracy was like 100%, and the accuracy that is seen here is gonna be about 30%, right? So let's take a look at the outputs here, or at the violations. I'm gonna scroll down because I'm printing a ton of information, and here you can see the violations. Look at this. I have a violation that says that the weighted F2 score of 0.35 is less than the threshold of 1. Remember that when we generated the constraints, this model, I think, got every single test case correct. So the accuracy was 100%, the recall was 100%, all of the metrics were through the roof. So that's why here I get that this should be 1, because that's how I tested it. And you can see here, yeah, the weighted F2 is only 35%. The accuracy is only 35%. Yeah, I'm just picking a random value out of 3. That's why I get all of these violations. But anyway, this is a cool way of seeing how you can get that information just by looking at the results of the monitoring job. Of course, we also have the CloudWatch. And if I go to CloudWatch, if you go to CloudWatch, you can go to all metrics, browse. I'm going to go all here. So I'm going to get to the custom namespaces of the metrics. And there's going to be one that's called model metrics, SageMaker, endpoints, model metrics. And then you click on model monitoring here. And then you're going to get all of the metrics that SageMaker is reporting on. let me just select accuracy here and print accuracy for the last day or 3 days. And you get like here, for example, model metrics is this red here. So it's down here. So you get model metrics. You can see there that it was a 0.35%. If I keep that monitoring job running, what's going to happen with this chart is that it's going to start adding every time it runs. It's going to report on all of those metrics. And you can see like a continuous line of how the metrics or how the accuracy of your job is running, or precision or recall or F1 score, whatever you decide to print on this chart. That is how you can keep an eye on how your monitoring job is running. Something important that I forgot to mention in the previous session, but I'm gonna mention here. When you're done testing this, make sure you turn off the data monitoring job and the model monitoring job. And down here, I have a section called tearing down resources. Remember, we've used this session before to delete an endpoint. Well, in tearing down resources, you can come here and delete the monitoring schedule. So you can come here and you execute this line. And if there is a monitoring schedule, it's going to delete it for you. And if there is like a model monitoring schedule, this line is going to delete it for you. I might take these two lines, these two sections, and put them within the actual sessions, like the data monitoring session and the model monitoring session. I might just add them there so it's easier for you to find. But either way, just make sure you delete those monitoring schedules because you don't want them to keep running while you're not paying attention. That's it. In the next session, we're gonna see something very interesting that you can do with deployed endpoints, and I'll see you then.